Now, in the past few months, I had the opportunity to work on logs, and there are a few insights that I managed to gather, and I feel they may bring some value to somebody else. So I am going to share them. Now, what is a log? A log is information about events that have occurred within a software application or system process. In past times, this definition would include something like a file that stores information about events that have occurred within a software or system process. But in these days, logs, we have realized that could be stored anywhere, or they could be displayed anywhere. Therefore, it's no longer accurate to enclose it in just files. And the things that you are recording are your errors, warnings, or whatever trace information that occurs in your application. Now, I'm going to first start with fundamentals, because as all things in development, a strong foundation will give you uh, more opportunities and will expand the possibilities you have later on in the process of development. Now, there are many fundamental laws or instructions you can follow when creating logs, but I'm going to mention a few that I feel are core and important when dealing with logs. Now, the first one is to log at the proper level. What that means is logs are basically separated into different critical levels. You have your trace and debug, which usually are more important in the debug phase, and the difference between the two just being that trace logs, uh, we do not expect to see trace logs in production, and debug logs usually trimmed down when we get into production. The info level is used for information that is useful to the app, but is not considered an error or anything of that sort. Now, warn and error are usually used for your error and exceptions. Warn, the difference between the two of them being that warn is not something that is considered uh, immediately dangerous. It could be something that might have an impact later in the application. Maybe something like a database call took much longer than what was expected. So warn is specifically for situations such as that. Now, critical is something that you want to really see, because critical is something that should immediately register danger to the user. So the less critical log entries you have, the better, because then it'll instill a sense of urgency when critical entries appear in the log. The second fundamental principle would be writing meaningful log messages. The idea behind this is to avoid inferring to the current context. Because in situations where a user has no idea about the source code or any idea about the workings of the source code of the code, but they are trying to fix an issue in the application itself, a lack of context might make things kind of difficult to handle. Then the next point will kind of shed more light into what I mean by writing meaningful log messages. The last point says remove log entry dependency and atomize and isolate every log entry wherever possible. The idea behind this is if your log entry depends on functionality, depends on an entry that is on a different part of the application, in a situation where that part is not touched, in the sense that there's no entry for that part, the log entry will lose meaning. Therefore, always make sure that you try and get as much context as you can in the exact entry that you're applying. Now, to look back on what you just said right now, the context in your messages. I have a few examples here that will give you an idea what is meant by that. So a message like transaction failed, while it's explaining exactly what happened, it has no context in the sense that we have no idea what happened and where it happened. So trying to expound a bit more on the cause and the the context of how it happened will go a long way in assisting whoever is going to be using those logs to solve issues. The same applies for exceptions. You have to give us it is suggested, or the best practice is to give us more context with regards to the exception. What were you trying to do, and why it happened? It is a practice that will give you better chances of actually solving your issues when going through logs. Now, the next point I want to make is make log entries machine possible, but also human readable. The idea behind this is humans are not really good at handling large amounts of data, but machines are. So if you strike a good balance between machine passability, meaning it's easy for a machine to pass the information that is contained in a log entry, as well as readability, in the sense that when the user looks at the log, it is immediately apparent what the log is about. So things like including the log level or using JSON to as part of the log information will allow for easier passability when we want to get that information transferred into a different application or different instance of something, basically. Now, the next point is a bit of a no-brainer, but I felt I had to include it in there. That is to not log sensitive information. If in addition to that, you have to make sure that you're following the regulations of your specific country of operation, because different countries have different ideas of what's considered sensitive information. So for South Africans, an ID number is considered something sensitive. It is not wise to have an ID in a log. So the next one is think of your audience. So now, who's the log for? Is the idea behind this is for situations where the log is for example, is for a user who's trying to debug functionality in the front end somewhere, will be different from a log that is required by a developer who is working through the development of an application. So knowing who the audience for the log is will help in determining what to put in the log. And the next point is maintaining a consistent structure across all logs. Maintaining this structure will allow you to kind of create general code, or when you're configuring stuff to interact with your logs, it will simplify the process of integration in that regard. Now, the last point I'd like to make is do not reinvent the wheel unless you have to. There are many login packages or modules in many of the common languages that we use on a daily basis, and it is suggested that you rather use that unless you want extra functionality on top of that, which just means that you can expand further on it. And to further iterate on that, I'm just going to give you a brief explanation or a brief demonstration of how the Python logger module works and what advantages it gives you. Now, to initialize the logger, you just call the get logger functions on the logging module. Now, the advantage of this is Python uses instances. So wherever you call that particular name for a logger, it will give you that instance of that logger. So it means that you don't have to worry about accessibility of the logger itself. So, and the next thing is formatters. We mentioned that keeping same format or keeping consistency throughout your logs is best practice. So Python's logging module affords you a default formatter that allows you to specify how you want your logs to appear. And it has a lot of functionality, like you don't have to worry about time, it'll do that automatically for you. You can choose between a timestamp or human readable time. And it goes back to the thing I mentioned before where I said you have to strike a good balance between human readability as well as machine possibility. I don't know if it's a word, but I'm making it one today. Now, the other advantages that this has is For example, in Python, the logger itself is thread safe. By using a thread locking functionality, it ensures that if multiple applications or multiple services or functions are accessing the same logger, there will not be any confusion in race conditions and so forth, anything of that sort. There's also filters in this as well, which is something that allows you to filter the, like it allows the user to specify if the log information they give is worth logging or not. So you can specify if something has a specific text in it, that the logger shouldn't log it. So every time it has to log an entry into the file, it'll check first with the filters if uh, this is something that's log worthy or not, as well as formatters, as I mentioned earlier. Now, I want us to shift our perspective slightly. In the previous slides, we've been talking about logs as entries or something we can go back into, like replay events and see what might have gone wrong. Now, I want us to start looking at logs as a data source. And we're going to start looking at aggregation and what that means for logs as well. Now, aggregation is to collect or gather information as a master or whole for the sole intent of data analysis. So to expand further on that, the benefits of this is if you start looking at logs from a point of view of a data source, you get the benefit of analysis, meaning you can run analytics on your logs, and with a specialized software, you can have a centralized location to access all of your logs, as well as optimized search functionality, which as a person who works in prod support, I can attest to the need to actually run searches for specific things when trying to troubleshoot issues. So that functionality is key for specific functionality, for specific sections of specific positions in a DevOps environment. Now, the main or the most important thing here is observability. And what observability is a measure of how much can be inferred about the state of an application by the outputs that it gives. So looking at logs from a data source point of view gives you an opportunity to kind of improve observability on your applications. Now, I had the opportunity to look at two applications that afford the user aggregation and analytic capabilities. And those are the elk stack, which is comprised of Logstash, Elasticsearch, and Kibana. Logstash is responsible for the collection and the aggregation of the data, but Elasticsearch is actually responsible for the indexing as well as storing of the whatever Logstash gives to it. Kibana is responsible for analysis and visualization. On the other hand, Grafana, on the Grafana side, we have Promtail that's responsible for the data collection. And then Promtail feeds into Grafana, Loki, which will be responsible for aggregation and storage, as well as indexing. And then Grafana will be responsible for the visualization and analysis. Now, both have various advantages and disadvantages, but I'll just expound on a bit on the functionality that the two can offer, in the hopes that every team can infer what value can be drawn from using either or. Now, the similarities between the two are they both have visualization, and they're expanding their scope in the sense that they are constantly increasing and adding more functionality to their systems. They are both open source, but they both have added functionality in the sense that Elasticsearch has things that are considered free to use, but then there's also extra functionality that you can pay for on top of that. Now, uh, from a box from the free to use application accessible from the free to use features that are available to us. In the Grafana side, we have access control as well as metric analysis. And on the Elasticsearch side, there is no access control. That's a feature that you can add on top with by paying for actually. So now these are the differences between the. As you can see, there's a lot of similarities between the two. It also depend on the team itself on what functionality they really want to draw from this. Now I'm going to demonstrate using Grafana exactly what I've mentioned so far in this talk, in the hopes that teams can start drawing insights as well as see where they can draw value for their clients as well as for the teams themselves. Now, Grafana in and itself is a powerful tool. There are many things you can do here with time series data and so forth. We're just going to take a little section from that and look at how we can handle log information in Grafana. Now, the first method I'm going to show you is the log, the querying of information that I mentioned earlier. Um, both applications have querying capabilities, but it's handled differently in both. In Elasticsearch, the information is actually indexed according to the words. So weights and weights will be applied to each and every word, and as well as the sentence as a whole. So when you're actually querying the data in Elasticsearch, you're actually querying it's a full text query instead of uh, in here in Grafana, where it's actually more based on the label as well as just searching what it'll give you full text capabilities, but it's not indexed that way. Now, to demonstrate what I mean by that is both have query languages that you can use to query both, and they both have API accessibility. In this case, I'm just going to demonstrate what I mean by optimized search functionality. Say, for example, you want to see all of the error uh, entries in your logs. So they are. I'm going to demonstrate a few of the query language methods. There are a few. I implore that you take the time to look at the documentation to get further information on or what exactly you can run on Grafana. So here is an example of how you would get specific information according to the query that you run. It has exact strings, so in the sense that wherever whatever log entry has this part of the string, it will match and it will appear here. And then there's also regex expressions, which, as you know, with regex, you pretty much have the world in your hand. So I can look for everywhere where there's error or info, and it'll return all of those cases. You can get as complex as you want with the queries themselves. For example, if you wanted to, for example, in our situation, we work with reference numbers all the time. So in a situation where you want to check the history of what might have happened with a particular reference number, this particular functionality would go a long way in actually simplifying the process. Because after searching what you want, you can also show the context, um, which basically just means return the surrounding log entries for that particular search. So I'm sure you can imagine the power that you have with such functionality. It'll speed up your troubleshooting, your error handling, and so forth, incident handling, and so forth. Now, the next part I'm going to show is the analysis part of Grafana. Um, Obviously, this will depend on an application by application basis, in the sense that it's up to the team to decide what would be valuable to them or their clients. In this case, in my example, I'm just showing the information about access to a server. Now, it's showing information about the post and the gets, which what failed and what was successful. And I'm gonna just go inside and just show you exactly how easy it is to set up something like this. Now, I have 4 labels, as you can see here, and each and every one of them is basically just me checking uh, with a logql, which is the language that is used here to query the log data, the log information that I have. Now, uh, Grafana has 2 key methods that allow you to gain metrics from your log information. There is count over time, which is basically a count of information over a specified period of time. For example, here we are looking at the count of all successful get requests in a 24-hour period. And then there's the next one is called rate, which is more like a frequency. So in the in a 60-second period, what was the frequency of get requests that was successful? And you actually have a lot of control over how you display your information. So, for example, you can you can display the information in a horizontal way or a vertical way. You can actually also display all the values over time. So, as I said here, it's over a 24-hour period of time. It'll just keep on showing you over 24 hours, for example. Then you also have various types of graphs that you can select from. As I said earlier, it'll also depend on the application that you're looking for. So whatever you feel might draw value for your clients, you can pretty much configure here. So if you feel like this information will be represented better as a graph, you can use a graph instead of a bar gauge or anything of that sort. Now, to yeah, the other examples I have here are types of graphs that you can actually set up here. Here I'm just getting a read or a count of the entries in the logs over time. So every minute it'll check the amount of errors that come through, the amount of ones and so forth. This could be useful for situations where you are watching for specific things. So you want to see the amount of errors that come in over a specific period of time. That could be information that's useful to a developer to kind of make further enhancements to the application using this information. Now, the other thing that I wanted to mention here is the alerts, which is something I also feel could be useful in the way we handle our applications in these days. So the way you set up applications is set up notifications is you have to set up a notification channel, and what this is a manner in which Grafana will notify people. It could either be email or it could be any one of the common communication sites or social sites that we use in our teams. For example, in our team we use Slack. We actually touch Telegram as well. So you can have as many as you want, and you can send notifications to those particular applications on specific events. Now, if I were to, for example, I actually set up a single alert, and I'm going to just walk you through it and show you what it does. Now, here what I did was I set up an alert to count. So it'll send an alert if the number of errors over a minute are above a specific number. If the number exceeds what I expect, it'll send me a notification. So this also affords you the opportunity to be more preemptive with your incident management instead of being a bit more passive. There are a few more things I wish I could touch on with regards to this, but unfortunately we ran out of time. So thank you for taking the time to listen to my talk.